Did you ever stop to wonder how many times you use your bones in a day? From the moment you rise from bed, your skeletal system is hard at work, providing support, enabling movement, and protecting vital organs. Our bones are the unsung heroes of our bodies, and they are far more dynamic and complex than we often give them credit for. This is why understanding the skeletal system is not only fascinating but crucial, especially for those embarking on a journey into the nursing profession. In this video, we will explore the intricate world of the skeletal system. We will delve into its anatomy and physiology, using an engaging 3D animation to make the complex simple and the abstract tangible. Whether you're a curious mind eager to learn or a nursing student preparing for exams, this guide is designed to make the skeletal system accessible, engaging, and memorable. So brace yourselves. Get ready to dive into the fascinating world of our skeletal system. The human skeleton, a marvel of nature's construction. But what makes it so special? You see, our skeletal system is essentially the infrastructure of our body. It's made up of more than 200 individual bones, all working together to perform several vital functions. First, the skeleton provides support. It's like the framework of a building, holding our body upright and giving shape to our form. Next, it offers protection. Think of your skull safeguarding your brain, or your ribcage shielding your heart and lungs. Then, there's movement. Your bones work in tandem with your muscles to enable a vast array of motions. From a simple wave to running a marathon, it all hinges on your skeletal system. Moreover, the skeleton is a storage facility, hoarding essential minerals like calcium and phosphorus. And let's not forget about blood cell production. Your bones house marrow, a factory for creating new blood cells. That's the skeletal system in a nutshell, but let's dissect it further. Now, imagine a closer look at the intricate details of our skeletal system. To truly understand its complexity, we dive into the two main parts, the axial and the appendicular skeletons. Let's begin with the axial skeleton, the central core of our body. It consists of the skull, which houses our brain and sensory organs. Then we have the vertebral column, our body's main support structure, that extends from the base of the skull and ends at the small of the back. And finally, the thoracic cage, a protective shield for our heart and lungs. This cage, commonly known as the rib cage, is made up of ribs and the sternum. Now, let's shift our focus to the appendicular skeleton. This part of the system includes our limbs and girdles. The upper limbs, our arms, are designed for precision and a wide range of motion. Our lower limbs, the legs, are structured for strength and stability, enabling us to walk, run, and jump. The girdles, namely the pectoral and pelvic, connect these limbs to the axial skeleton and play a crucial role in movement and balance. As we explore further, we find that our bones are not all the same. In fact, they come in 4 distinct types. The long bones, like our femur and humerus, provide strength and mobility. Short bones, such as those in our wrists and ankles, allow skilled movements. Flat bones, including the skull and ribs, offer protection to our vital organs. And lastly, irregular bones, like the vertebrae and certain facial bones, have a variety of functions, including protection, attachment for muscles, and facilitating body movements. Isn't it fascinating to see how these bones come together to form our skeletal system? But these bones are not just rigid structures, they are living, growing tissues. Let's dive a bit deeper into the physiology of the skeletal system. Bone formation, or osteogenesis, is an intricate process that begins even before we are born and continues throughout our lives. It all starts during the embryonic stage, when the skeletal system is nothing but a framework of cartilage and fibrous structures. As we grow, this framework starts to harden, a process known as ossification. Ossification is facilitated by cells known as osteoblasts, which synthesize and secrete a matrix of organic compounds, thus laying the groundwork for mineral deposition. Now, once the bone is formed, it doesn't just sit idle. It continues to grow, adapt, and remodel itself. This is where our bone cells, the osteocytes, come into play. These cells are the most common type of bone cell and are essential for maintaining bone mass. They also play a crucial role in the communication network within the bone, signaling other cells when there's a need for repair or remodeling. But wait, there's more. There are also cells called osteoclasts, which might sound a bit like villains in this story, but they are absolutely necessary for our bones' health. Osteoclasts are responsible for bone resorption, which is the process of breaking down bone tissue. This might sound counterproductive, but it's an essential part of the remodeling process, making way for new, stronger bone to be built by our ever-diligent osteoblasts. And here's something to marvel at. Our entire skeleton is replaced about every 10 years. That's right, every 10 years you have an entirely new set of bones. This is due to the constant work of osteoblasts, osteocytes, and osteoclasts, working round the clock to keep our skeletal system strong and healthy. So, our bones are not just about providing structural support or protecting our organs. They are vibrant, dynamic, and constantly changing, growing, adapting, and remodeling themselves to meet our body's needs. It's a fascinating world within us, isn't it? So, our bones are not only structural support, they are dynamic and constantly changing. So, what have we learned today about our skeletal system? We've embarked on a fascinating journey, exploring the intricate framework that gives our body structure, protects our organs, and enables movement. We've delved into the basics, understanding the primary functions of the skeletal system. We then moved on to the anatomy of the skeletal system, discovering the 206 bones that make up our bodies, each with its unique shape and function. We've explored the long bones in our arms and legs, the short bones in our wrists and ankles, and the flat bones protecting our vital organs. The journey didn't stop there. We ventured into the physiology of the skeletal system, learning about bone marrow, the production of red and white blood cells, and the role of calcium and phosphorus in bone health. As we draw this journey to a close, let's remember the importance of understanding the skeletal system, particularly for those in the nursing field. Remember, every bone in your body has a story to tell. Keep exploring, keep learning, and see you in our next video.